Thank you, Noah. I appreciate it. Yesterday we talked about the idea of probability distribution and working with probability distribution. We're talking about calculating the mean. Once again, this is a combination of statistics and probability now. Okay, we start integrating the idea of what we talked about statistically wise into what we are now going to be talking about with respect to probability. Okay, and how do we incorporate that? We can calculate the mean, we can calculate the variance and the standard deviation for probability distributions. The mean is the sum of outcome times probability of the outcome. Once again, this is outcome. Whatever that outcome is, whatever the outcome is, and this is the probability of the outcome. Whatever that probability is, you multiply those two together and we add them up then. That will give you the mean. When we're talking about the variance, we have the outcome squared times probability, but we have to remember to subtract off the mean squared. This is typically the one part that we tend to forget about. Okay, we have to make sure we subtract off the mean squared, and we can take the square root of the variance to get the standard deviation. We're talking about probability distributions. It's basically a histogram where we have outcome of the sample space and the probability of the outcome, and we just do dots and we draw our lines to those dots of probability, the probabilities. When you're dealing with a frequency table like you had in problem number 7, you have to create probabilities. So you'll have to deal with one extra line on that worksheet there. And when you have a frequency diagram, just convert things into probabilities. Solutions were provided for you. Questions that you have on any of the problems. Again, the reason why I provide the solutions is for you to check your answers. That more or less puts the onus on you that you need to take care of your responsibilities, the educational responsibilities here. Questions you have? Not difficult material, but hopefully you're keeping up with it, because it will catch up to you real quick. We will continue with probability distributions, but today we're going to work on what is called a binomial probability distribution. And when we're talking about a binomial, it's very similar to what we just did, but when you're dealing with binomial, bi means 2, you're only going to have 2 options in regards to your sample space. When you're talking about a binomial distribution, we have 4 conditions that need to be met. The first 2, you have 4 conditions that need to be met. there must be a fixed number of trials. Whatever the trials are, you must have a fixed number of trials. You must have a fixed number of trials. In each of these trials, you must have exactly 2 outcomes or can be reduced to 2 outcomes. You will have 2 outcomes or you can reduce it to 2 outcomes. So you have a fixed number of trials and you're going to have 2 outcomes. For example, true and false question, true and false test. You have 2 outcomes. It's either going to be true or false. You don't have a true, false, or maybe. It's either true or it's false. You have a true statement or false statement. Shooting a free throw. You either make it or miss it. You make it, you get a point. You miss it, you don't get a point. If you hit the rim, you don't get a half a point. Okay? You either make it or you miss it. 2 results: true, false, make, miss. If you have a multiple choice test with 4 options, this can be reduced down to 2 options or 2 results. You will either get it correct or you will get it incorrect. Even though you have 4 options with a solution, you have an A, B, C, D. Or if you're taking the ACT test, you have 5 options. One of those is correct. The other 4 are incorrect. So your 4 questions or 4 options or 5 options on a multiple choice test can be reduced down to either correct or incorrect. That makes it binomial. Third property. The outcome of each trial is independent. The first question being false has no bearing on the answer of the second question being false or true. As I talked about the deranged teacher that has 10 true and false questions, and every one of those is false. Each outcome is independent. You shoot a free throw. You miss it. Does that mean I'm going to miss the second one? No. You can make it. Or if you make the first one, does that automatically mean I'm going to make the second one? No, it doesn't. Each trial is independent of each other. And the last one. The probability of each trial remains the same. Probability of each trial remains the same. You have 4 or 5 options on a multiple choice test, and you're guessing. You're sitting there and you have 10 questions left on the ACT test, and the professor or the proctor that's watching over you says you have 1 minute to complete the test. So you go to the guessing mode. Okay? You guess on the last 10 questions. Each one you have equally likely probability of missing or making. When we're talking about a binomial distribution, it's the outcomes of binomial experiment and corresponding probabilities of these outcomes. Okay, yesterday we talked about probability distributions. Probability distributions, you have outcomes of the sample space and probabilities of the outcomes of that sample space. Now I'm going to talk about binomial distribution. You just now have two options for a sample space. Your sample space gets reduced down to two options. Now, how I will describe the two options are, you have one of two things. You have P of S, which is the probability of success, or you have P of F, which is your probability for failure. You're either going to have success or you're going to have a failure. That's the easiest way to describe it. Now, you had to put in your mind, what is a success and what is a failure? Sometimes a success is a negative consequence because of the conditions given within the problem. But when we're talking about binomial experience, what you should think about is when going through these problems, I'm either going to have success or I'm going to have failure. When you talk about little p here, little p is your probability for success, and little q is your probability for failure. So p is your numerical value for success. What's the probability for success? Q is the probability for failure. Let's talk about the ACT for a minute. ACT, you have multiple choice, 5 options. You have the ACT, you have a multiple choice, you have 5 options. Once again, Proctor says you got 1 minute left, you have 10 math problems still to do. You're not going to have time to go through 10 math problems. So you're going to guess on the last 10 math problems. What's your probability for success here? You have 5 options and you're guessing. What's the probability for success? 20%. How'd you get it? I'm sorry, what? There we go. I have 1 correct answer out of a total of 5. I have 1 correct answer out of a total of 5. So my probability of success is 1/5, which is 0.20. Probability for failure? 80%. Because I have 4 out of the 5 that are incorrect. So you have 4 out of the 5 that are incorrect. You have 1 out of 5 that are correct. So if you're guessing, you have a 1 out of 5 chance of getting the correct answer. Now, my suggestion to you, if you're going to be in that situation on the ACT test, don't zigzag. Don't zigzag the last ones. Go straight down the column. Go straight down the column. Don't zigzag. You go straight down the column, you're going to have a chance of getting 2. If you have 10 questions, you have 2, maybe 3 of them that are going to be correct. If you zigzag, you may miss them all. Go straight down the column. Play the odds. Probabilities. P of S. Probability for success is P. Probability of failure is Q. Once again, it's just a numerical value. It's a numerical value. What is my percent chance of getting correct or incorrect? N is your number of trials. How many trials? We had 10 ACT questions that we were guessing on. N would be 10. How many trials would you have? X is your number of successes in N trials. How many successes are you going to have in N number of trials? X will be in between 0 and the total number of trials that you have, N. In a binomial experiment, the probability for exactly X number of successes, okay, is signified by P of X. I want to have X number of successes. How we calculate this? As we calculate this by N divided by N minus N times X. Times P to the X times Q to the N minus X. Now, if we take a look at this first coefficient here, we've seen this before. What this is this is just NCX. This is NCX. So what this gets reduced to is NCX, P to the X, Q to the N minus X. Once again, N is your number of trials. X is your number of successes. You have NCX times the probability of success to the number of successes. This is probability for success to the number of 2 successes times the probability of failure to the number of failures. So you have the probability of success to the number of successes times the probability of failure to the number of failures. Let's go back to the last ACT question. What would be the probability of guessing 3 correct out of that 10? Okay, probability of guessing the 3 correct out of the 10. How many questions we had? We had 10. So this is our n value. So we have 10 C3 because we want 3 exactly. We want to guess exactly 3 correct. So we have 10 C3. The probability for success we said was 0.2. So the number of successes times the probability of failure, 0.8, to the number of failures. So now it's a clickety-clack exercise where I'm doing 10C3, 0.2 to the third times 0.8 to the 7th power. Go ahead, clickety-clack it through. What is our probability? And you can clickety-clack that straight through the calculator. You can go 10C3 times 0.2 to the third times 0.8 to the 7th. KYC, know your calculator. Grace, what did you come up with? 0.201. Yes, no, maybe so. So we have a 20.1% chance of guessing exactly 3 correct. We have a 20% chance of doing that. Now, what we are basically doing here, we are using our multiplication principle where we had 10 questions. We have 3 of them that are correct, 0.2, 0.2, and 0.2. Then we have 7 of them that are incorrect. And we will multiply these all together. Now, where this comes, the 10C3 comes in, that is a combination where order is not important. Order is not important. So I can go 0.2, 0.2, 0.8, 0.2, then the rest of them 0.8. Or I can go 0.8, 0.8, 0.2, 0.8, 0.2, 0.8, 0.2, and the rest 0.8s. Order is not important. That's what this does right here, the 10C3. It juggles them all around. But what we're using is the multiplication principle and the word and. Okay, 3 coins are tossed. What's the probability of 2 tails facing upwards? Okay, or I'm flipping a coin 3 times. What's the probability of 2 tails up? Well, I'm flipping a coin 3 times, so my n is 3. My success is a tail. What's my p-value? What's the probability for a tail? Probability for failure.
Oh, for failure?
Probability for failure. I'm flipping a coin, heads or tails.
Oh,
0.5. Probability for failure, 0.5. I want 2 of them are tails. I have 2 of them are tails. So what's the probability of getting 2 tails? So I have NCX, 3C2, P, probability for success to the 2nd power, probability for failure to the 1st power. Jack, what do you come up with? 0.375. Now, if we take a look in your book, okay, back in your appendix, Appendix A, my book, it's A8 in the back. Okay, it should look like this. Okay, you're going to need your books for some of your problems. A8, A9, A10. Just look on somebody if you don't have a book. What you have here is a binomial distribution table. If you look in the very left-hand column, what you have is you have at the top an N and an X. That corresponds to your N and your X here. Along the top of the table, you have the p-value. So you can go with respect to a p-value. In this case, we have an N of 3. So if I go down to my N value of 3, which is the second group, I go to the X of 2 within that group. So we have 3, then we have a 0, 1, and a 2. We go to the 2. And then we slide our finger across to a p-value of 0.5. We get to 0.375. If we take a look at the ACT question, we have an X of 10. I'm sorry, N of 10, an X of 3. So let's go to the top of page A9. Go to the top of page A9. Where the N, underneath the N, we have a 10 there. We slide down our X to the number 3. Our probability for success is 0.2. So I'm going to slide my 3 line over to 0.2. And you get a 0.201. So this calculates probabilities for you. Now, the problem with this is you have these probabilities up here, and that's the only probabilities that you have. If I give you a 0.73 as a probability, you're going to have to go through the calculations here. It was found that 60% of American victims of healthcare fraud are senior citizens. 10 victims of healthcare fraud are chosen at random. Find the probability that exactly 3 were senior citizens. So we have 10 victims, we're choosing 10 at random. So our N value is 10. %60 of the victims are healthcare fraud, are senior citizens. We want to know exactly 3, probability of exactly 3. Now, my success here is not really a success, because if you get caught in healthcare fraud, that's not a good thing. But for our purposes in this problem, the idea of success is you're choosing 3 people that are senior citizens that are been a victim of healthcare fraud. So our probability for success is 0.60, even though we don't want that, it's a negative thing. But for the problem is 0.60. We want to know exactly 3. So the number of successes we want is 3. If my probability for success is 0.60, that means my probability for failure would be what then? Ethan? 0.4. So we have our 10C3, the probability for success to the number of successes. So we have 0.6 to the third, that's probability for success, the number of successes, times the probability of failure to the number of failures. Once again, go ahead and try it, just do your calculations here. We're going to go to the book in the bottom one here. You can check your answers with the book. Once again, you got to get used to both of these ideas here, because if I don't give you something that you can find in the book, then you're going to have to utilize this right here. We'll go to what the book is useful for, and I will go with these types of problems on a test in the next one where I can use my book and I can pull up values from my book, so I don't have to do these calculations about 1,000 times. What do we come up with, Ethan Farnsworth? 0.042. All right. Probability that at most 2 victims are senior citizens. At most. That means we have the probability of 0 plus a probability of 1 plus a probability of 2. Now this is where we're going to go to the book, because I'm not going to want to do these. If I want to, I can do these calculations 3 times. But if I have to look up 3 different probabilities, let's go to the book. Let's go to the 10. I have to go to the p-value of 0.6. I have an x value of 0, an x value of 1, and x value of 2. So I can go to the book and just go down the column and get the 3 values from the book. And this is what the book is useful for. And like I said, what I will do on a test, I will make sure that you can use the book for values that are like this. When I'm just doing one single value, you won't be able to use the book. So I can go to the book and pull down 3 values at 0.6. Well, the first 2, you got 0.000 for 0, then 0.002, then 0.011. That I can add up those 3 probabilities. If I did these right here, I would come down to these 3 probabilities. So you have 0.013 or 1.3% chance. When we talk about binomial distribution mean, how we can calculate that is just taking n times p. So for your binomial distribution mean, you can just take n times p. For your variance, this is n times p times q. And then once again, your standard deviation is the square root of the variance. Maybe. Come on, there we go. The square root of the variance. Once again, mathematically is not advanced with respect to the mathematics, but this is a concept that none of you has ever dealt with. Which is more the struggle. The first time you go through certain things, it's a little bit more of the struggle. So that means you need to make sure that you get your practice in that you need to have. And once again, what I will do is I will give you values when you're dealing with exactlies that you are in problem A. When you're dealing with the exactlies, utilize your NCX. Get yourself some practice with the NCX. When you have parts B and C, when you're doing the more than or less than a value, use your book. So this will give you practice on both of these with respect to exact values in part A using your NCX, and then parts B and C, use your books and pull your values from your books. So you get practice going doing both of these. Questions? All right, you have about 3 or 4 minutes. The rest of the time is yours.